Okay, so we are now ready to just work through some examples. But before we do that, let's do a quick review of some antiderivatives. All right, let me switch to a color that'll show up better. So let's just quickly review. If you had the antiderivative of 1 over x with respect to x, that's straight off of the memory list. You need to know that is the ln of the absolute value of x plus c. We saw in some previous examples, we did U substitution or used U substitution to figure out that if I had something like x minus 1 in the denominator, that would simply be ln of the absolute value of x minus 1 plus c. And likewise, if I had the integral of 1 over x plus 4 with respect to x, integrated with respect to x, that would be ln of the absolute value of x plus 4 plus c. All right, so we've seen those. Now the key was on these last two examples, if I take the derivative of the denominators here, the derivatives are just 1. So whether I let u equal x minus 1, or in this case, u equals x plus 4, in either case, du dx is equal to 1. So we can say in both cases that du and dx are the same, which is why they work out so nicely. We're going to continue to work with this with linear factors. So let's consider what happens if you had the integral of 1 over, let's use 3x minus 2. So maybe based on this, you would guess this is going to be wrong. You might guess, oh, it must be ln of 3x minus 2. So if you guess that and then you go to check it, you would need to take the derivative. Let's just assume that we don't actually need to assume that it's positive. So we'd have to chain rule this when we take the derivative. So I would have 1 over 3x minus 2, but then I would multiply by the derivative of what's inside, and that would be multiplied by a 3. So it looks like if I do that, it's 3 times too big. So I'm suspicious that I need to have a 1/3 out there. If I put a 1/3 out there, that will in fact give me the right answer. Okay, so the quick reverse of the substitution is to just kind of guess and check the answer. You know that if you put an extra factor of 1/3 out there, then the derivative of the left-hand side, will in fact be the integrand. Oh, I should have a dx in my integrand. So that would be the correct answer. We can also show using U substitution how to get there. If we let U equal 3x minus 2, du dx is 3. So du equals 3 dx, and dx must be du over 3. So we could have written the integral of 1 over 3x minus 2 with respect to x. We could rewrite that as the integral of 1 over u, and instead of dx, we could have du, and du over 3. And therefore, this would be 1/3 the integral of, I'll write it as du over u, or 1/3 ln of u plus c. And when we substitute back in for u, we will in fact get what I expected there. So the key is if you have a linear factor in the denominator whose derivative is 3, then you would want to put an extra factor of 1/3 in front of the natural log. If the derivative were 5, you would want to have 1/5. The derivative were 1/2, you'd want to put a 2 there. So we'll keep that in mind as we do a couple of problems. All right. So for problem 1, okay, so we'll just kind of do a little pause and play here as we go, but let me start with the integral of 1 over 2x squared plus x. This one should be relatively easy to factor the denominator. So let's write this as 2 factors. So try to figure that out. Hit pause. Hopefully you realize the factors, both terms have an x. So the factors are x and 2x plus 1. You don't need to put the first factor in parentheses, but you can. Oh, and we need to write with respect to x, or we don't have an integral. So I can now rewrite this as what I need to do is use partial fractions now. So I'm going to, on the side, write a partial fraction problem. So let me change my pen color. Let's make this blue. So we have to figure out what 1 over x times 2x plus 1 can be rewritten as. So we're now doing a partial fraction problem. So notice the integrand has to be rewritten. So you need to write this as something over x plus something over 2x plus 1. All right, and we don't know what those somethings are, so we call them a and b. Notice we're only working with linear factors. Y, by that I mean if I were to graph y equals x, it's a straight line. If I graph y equals 2x plus 1, it's also a straight line. So those are linear factors. So we know that that must be true. Now remember, the next step when you were working with this is to multiply by the entire denominator. So when you do that, the left-hand side becomes 1. Pause and see if you can work out the right-hand side for step 1. Okay, so the right-hand side should be a times, when you multiply through by x times 2x plus 1, a factor of x divides out for the first term on the right. When you do the same thing for the second term, the factor of 2x plus 1 divides out. So that's what you have. And remember, we want to distribute. If you wish to do that step and the step I'm about to do together, this is okay. So we need to figure out how many x's we have. We have 2a plus b times x plus 1 left over. Okay. Oh, I made the same mistake I had made earlier. This 1 is not a 1, it's an a. Be sure that you note that was an a, not a 1. So this is not a 1 here. This is an a. Okay, I was going to have my 1 cancel out and give me a 0. That I knew that was going to be a problem. So recall, there are 0 x's on the left. So what does that mean? That means 2a plus b is how many x's you have, must be equal to 0. And also what's left is a, that must be equal to 1. So a has to be 1. Let's substitute over 2 times 1, that's 2, plus b must be 0. So b must be negative 2. All right. So I can rewrite the original expression, okay, as, let me just come up here. Yeah, put it in over here. Since we know what a and b are, we can say, this must be the integral of a over x. So let me put this all in parentheses. A over x was 1 over x plus b. Oh, b is negative 2. So let me subtract, put a minus sign here. Minus 2 over 2x plus 1. All right. And that will all be integrated with respect to x. Okay. So let me bring that down below here, and we'll redo this problem. So we're trying to figure out what the integral of, and I'll write this in 2 terms, 1 over x dx minus twice the integral of 1 over 2x plus 1 with respect to x. This goes back to what we had just reviewed. See if you can figure out what the 2 antiderivatives are. So pause for a moment and see if you can write them down. Okay, you should have determined that the antiderivative of the first term is ln of x, and then we had to have 2 times, but be careful here, you're going to have 1/2 ln of 2x plus 1. Because remember, when we go back the other way with the chain rule, we would need to multiply by an extra factor of 2, so that will cancel with the 1/2 when we're working back the other way. You always tack on your plus c, and then let's simplify. So this will be ln of x, the 2.5 cancel, minus ln of 2x plus 1 plus c. And then we should remember our rules of logarithms. When we're subtracting 2 logarithms, we can rewrite this as ln of x over 2x plus 1 plus c. So this is probably the answer that you would see. So when you have the difference of logarithms, you can turn that into a division. All right, so that's example 1. Example 2. Let's work with the antiderivative of 1 over x squared plus 3x minus 4. I'll integrate it with respect to x. So we need to figure out how to rewrite that as a partial fraction. So let's switch over to red. Okay, we first need to figure out what the factors are. Right, so given that it's in this section, it probably factors nicely. This one, it should be clear that it has to be an x as the first term in both factors. And now with a 4, we can factor that into 2 and 2, or a 3 and a 1. And given that this middle term is a 3, I suspect that, oh, I'm sorry, not 3 and 1, 4 and 1. 3 times 1 is not 4. The difference of those is, in fact, 3. So I suspect that we're going to be working with a plus and minus in here because the last term is negative. We're going to want to add 4 and subtract 1. So those are the factors. Okay. Now we can notice there are just 2 simple linear factors. So we can rewrite this as 2 partial fractions. And we're going to put an a over the x plus 4 and a b over the x minus 1. Now see if you can solve for a and b without any further help from me. Remember, the first step is to multiply through by the denominator. So pause the video, see if you can figure it out, and I'll write down the answer. Okay, so I'm just going to quickly go through this now. Hopefully your answer matches. If not, kind of pause and look more slowly. A times the x plus 4 will cancel. The x minus 1 will cancel when we multiply through. So 1 is equal to ax minus a plus bx plus 4b. Group things together. That's a plus b times x minus a plus 4b. All right, so if I look at the left-hand side, there are no x's. So a plus b must be 0. And there's a 1 there, so negative a plus 4b should equal 1. Okay, solving these, I'm going to start with the left-hand equation. A is the negative of b, so subbing over the negative of, that's a negative a, so that becomes plus b, plus 4b equals 1, so 5b equals 1. B is 1/5. Sub back, a is negative 1/5. All right, so putting those together, we can say that we need to integrate the quantity negative 1/5 times x plus 4 plus 1/5 times x minus 1. So that's what we're going to integrate. Okay. Now we can rewrite that integral. We can as two integrals, and we can bring the constants out. So that's -1/5, the integral of 1 over x plus 4 with respect to x. And then we can bring out +1/5, and we can take the integral of 1 over x minus 1 with respect to x. Okay, so now pause and see if you can get the antiderivative from here. All right, so the antiderivative would have to have a -1/5 ln. These are simple ones where the derivatives of the denominators are just 1 plus 1/5 times ln of x, absolute value of x minus 1 plus c once we remove the antiderivative sign. Now this is looking like we could have a difference of logs here. Okay, so the best thing, let's take the 1/5 out, and we have ln of x plus 4, negative there, plus ln of x minus 1 plus c. We could reverse the terms if we wanted, so this would be the second term. So this looks like ln of a minus ln of b. So this can be rewritten as 1/5 the natural log of the x minus 1 is the positive term, and the x plus 4 was the negative term, so it goes in the denominator, plus c. This is the best answer. It's possible that you could take the 1/5 using rules of logarithms and put it up here, but we don't want to do that. This is probably the best way to express the answer. Okay, so let's do one more together. So this one will be a little bit trickier in terms of the factoring. It's not much harder to work with. So let's do the antiderivative of 1 over 6x squared minus 7x plus 2. With respect to x. All right, so we need to figure out what this is equal to. So let's set up a partial fractions problem. So on the side or down below here, we have 1 over, we're going to need to rewrite that integrand. It's quadratic, so there should be 2 factors, hopefully not any repeated ones. All right, so we have a positive 2. So this time I'm going to put in the second term of the binomials. I know it has to be positive 2 times, oh, it actually has to be a double negative. Since the middle term is negative, middle term is negative 7x, this will be a double negative in order to make this work out. So I have a -2 and a -1, all right? Now I'm going to need the right factors of 6. I could use 6 and 1, or I could use 3 and 2 in order to get everything to come out to a middle term of -7. And I believe to make that work, it's going to be a 3 and a 4. So I want to put a 2x here and a 3x there. All right. And then I can quickly FOIL that in my head to make sure I got this right. All right. And now, so those would be the correct factors. Now, I should have written that over one denominator. Whoa, eraser, there we go. So I could rewrite that way. Now see if you can take this problem to completion now. And in just a moment, I'll work it out quickly, but keep hitting pause and go as far as you can. And then play the video to catch up to where you are, and then pause again and see if you can go forward, and then play the video again to finish it. All right. I'm going to write this out now. This will be a over 3x minus 2 plus b over 2x minus 1. That means, switch colors here. I multiply by the entire denominator. 1 is equal to a times 2x minus 1 plus b times 3x minus 2. So 1 is equal to 2ax minus a plus 3b plus better 3bx minus 2b. And group 1 is equal to 2a plus 3b times x minus a minus 2b. There are no x's on the left, so 2a plus 3b must equal 0, and negative a minus 2b must equal the 1. Probably the easiest way to do this, say 2a equals 3b, so a, oops, negative 3b, so a equals negative 3 halves b. Sub over, it's negative negative, so 3 halves b minus 2b, I'll call it 4 halves b is 1. Looks like I have negative 1 half b equals 1. Slide on up. So that means that b is negative 2. I put that in for b and sub back over. A must be 3. That is correct. Okay, so what do we really have? We have the integral of a, which is 3. Let me go back and check out what my factors were again. Over 3x minus 2 plus b, oh, that's minus, negative in there. So we'll get out my eraser. So minus 2 over, I think it's 2x plus 1. Let me just double check. So 2x minus 1. All integrated with respect to x. Okay, so we've completed the hard part of the problem. Now we just need to get the antiderivative for both of those terms. Hopefully by now you can understand, oh, this, let's divide it into 2 integrals first. This will be 1 over 3x minus 2 minus 2 times the integral of 1 over 2x minus 1. We keep going, that's 3 times, and then remember when we do this antiderivative, it's 1/3 of ln of 3x minus 2. Quick chain, you need that 1/3 to counter the derivative of 3x minus 2, and then you're going to have times 1/2 ln of absolute value of 2x minus 1. Once again, that half and the 2, the derivative of 2x minus 1 is 2, so you need a factor of half to counter it, plus c. Okay, so this simplifies down to the ln of absolute value of 3x minus 2 minus natural log of absolute value of 2x minus 1 plus c. Use rules of logarithms to combine this into ln of 3x minus 2 over 2x minus 1 plus c. There is your answer. All right, so you'll have a chance to do some more of these in your homework.